Hello everyone, welcome to this video on real-world use cases of the request library in Python. The request library is a powerful tool for interacting with web services and APIs, and its versatility makes it essential for many practical applications. Whether it's automating API requests, building custom APIs, downloading or uploading files, or even scraping web data, request helps you handle it all with ease. In this video, we'll explore how to use requests effectively in real-world scenarios, and by the end, you'll have a strong understanding of how to integrate it into your projects. Let's get started. Automating API requests for data extraction. Automating API requests is one of the most practical and common use cases for the request library in Python. APIs, application programming interfaces, provide a standardized way to access data and services programmatically, allowing developers to retrieve, process, and integrate information into their applications. The request library simplifies this interaction by offering a straightforward way to send HTTP requests and handle responses efficiently. In the example, a GET request is sent to https://json placeholder.typico.com/posts, a free REST API that provides sample data for testing and learning purposes. The request.get method fetches the data from the API. If the request is successful indicated by a status code of 200, the response.json method is used to pass the JSON response into a Python list of dictionaries. Each dictionary represents an individual post. The program then iterates over the first 5 posts in the data, extracting and printing their titles. For example, the output might look like title sunt outfacere repellet provident okakati exceptori optio reprended title quaestesi. This automation process is incredibly useful in real-world scenarios, such as extracting data from APIs for analysis, fetching live updates e.g. weather or stock prices, or integrating external services into your application. It eliminates the need for manual data collection and allows you to retrieve large datasets programmatically in a matter of seconds. If the request fails, e.g., due to a network issue or an invalid URL, the program prints a failure message to inform the user, ensuring that errors are handled gracefully. In summary, the request library is an indispensable tool for automating API requests and extracting data programmatically. It empowers developers to access vast amounts of information from APIs easily, making it an essential skill for anyone working with data integration, web services, or automation. Building a basic API. Building a basic API client is an excellent way to streamline interactions with APIs, making your code cleaner, reusable, and easier to maintain. An API client is essentially a reusable class or module that encapsulates the details of making HTTP requests and handling responses. By abstracting the complexities of API interactions, an API client allows you to focus on the functionality of your application rather than repetitive request and response handling. In the example, an API client class is created to interact with APIs. This class accepts two parameters during initialization. Base underscore URL, the base URL of the API, e.g. https://json placeholder.typico.com/. Headers, optional custom headers that might be required for authentication or content type specification. The API client class provides two methods. Get, this method simplifies making GET requests to the API. It constructs the full URL by appending the endpoint to the base underscore URL, sends the request using request.get, and handles the response. The params argument allows you to include query parameters, and the response.raise underscore for underscore status method ensures that any HTTP errors are properly handled by raising exceptions for non-2xx source codes. Post, this method is designed for post requests. Similar to the get method, it constructs the full URL, sends a request using request.post, and raises exceptions for HTTP errors. It supports sending both form encoded data and JSO and payloads JSON. To demonstrate the use of this client, an instance of Epic client is created with the base URL https colon double forward slash json placeholder.typico.com forward slash. The get method is used to fetch posts from the post endpoint. The response, which is a list of posts in JSON format, is passed and displayed. For simplicity, the first two posts are printed to the console. This abstraction makes it easier to work with APIs in larger applications. Instead of writing repetitive code for each request, you can use the API client to handle all HTTP interactions. This approach is particularly useful when working with APIs that require authentication, consistent headers, or shared logic across multiple endpoints. In summary, creating an API allows you to encapsulate API interactions into a single reusable class, making your code more organized and maintainable. It simplifies the process of sending requests and handling responses, enabling you to focus on building features and integrating APIs seamlessly into your application. Interacting with REST APIs: get, post, put, delete. 1. Get request. Interacting with REST APIs is a common task in modern applications, and the request library in Python provides full support for all the major HTTP methods such as get, post, put, and delete. These methods allow you to communicate with APIs effectively, enabling tasks like fetching data, submitting information, updating resources, and deleting records. Among these, the get method is the most commonly used as it retrieves data from a specified resource. In the example, a get request is sent to https colon double forward slash json placeholder.typico.com forward slash post forward slash 1. This URL is part of the JSON placeholder API, a free REST API for testing and prototyping. The request.get method is used to make the request. If the request is successful, the server responds with the status code of 200 and returns the requested data in JSON format. The response.json method is used to pass the JSON response into a Python dictionary. This makes it easy to access and work with the data programmatically. For instance, you could extract specific fields such as the title or body of the post, or display the entire response for debugging or analysis. GET requests are commonly used to retrieve data from APIs such as fetching user information, retrieving product details, or querying reports. By using the request library, developers can seamlessly integrate API data into their applications with just a few lines of code. In summary, the get method allows you to retrieve data from a REST API, and the request library makes this process simple and efficient. By understanding how to use this method, you can easily interact with APIs and access the data you need for your projects. 2. Post request. The post method is used to send data to a server, typically to create a new resource. In the context of REST APIs, post requests are essential for tasks like submitting form data, creating records in a database, or sending structured information to an endpoint. The request library in Python simplifies the process of making post requests and handling the responses. In this example, a post request is made to the endpoint https colon double forward slash json placeholder.typical.com forward slash posts, which is part of the JSON placeholder API, a free resource for testing and prototyping API interactions. The data dictionary contains the information to be sent to the server, including fields like title, body, and user ID. These represent the attributes of the new resource being created. The request.post method is used to send the request, with the JSON argument automatically encoding the data dictionary into JSON format. This ensures that the server receives the data in the expected format without requiring manual conversion or additional headers. If the post request is successful, the server responds with the status code of 201 created, indicating that the resource was successfully created. The response body typically includes the newly created resource which is returned in JSON format. By calling response.json, the JSON response is passed into a Python dictionary, making it easy to access and display the server's output. For example, the response might include the newly assigned ID of the resource or a confirmation of the submitted data. Post requests are commonly used in applications that involve user input, such as submitting a blog post, uploading data, or creating accounts. The request library makes these tasks straightforward, handling both the request and response efficiently. In summary, the post method allows you to send data to an API to create new resources, and the request library makes this process intuitive and hassle free. By leveraging this functionality, you can easily integrate data submission features into your Python applications. 3. Put request. The put method is used in REST APIs to update an existing resource by sending new data to the server. Unlike POST, which creates a new resource, put modifies an existing one. The request library in Python provides a straightforward way to make put requests, allowing you to easily send updated data to an API endpoint. In this example, a put request is sent to https://json placeholder.typico.com /post /1, targeting the resource with the ID 1 on the JSON placeholder API. The data dictionary contains the updated information you want to send to the server. In this case, only the title field is being updated with the value updated title. The request.put method is used to send the request, with the JSON argument automatically converting the data dictionary into JSON format. This ensures the server receives the data in a structured format that it can process. The API processes the put request by locating the resource with ID 1, updating its title field, and returning the modified resource in the response. If the request is successful, the server responds with the status code of 200, okay, indicating that the resource was updated successfully. The server's response body typically includes the updated resource returned in JSON format. By calling response.json, the JSON response is converted into a Python dictionary, making it easy to verify the updated data or use it programmatically in your application. Put requests are commonly used in applications that involve resource updates, such as modifying user profiles, updating product details, or editing content. By using the request library, developers can seamlessly handle these updates with minimal code. In summary, the put method is a reliable way to update existing resources in a REST API, and the request library simplifies the process of sending and handling these requests. With its intuitive syntax and robust functionality, the library makes it easy to integrate resource updates into your Python applications. 4. Delete request. The delete method is used in REST APIs to remove a specific resource from the server. It is an essential HTTP method when implementing features like deleting user accounts, removing posts, or clearing specific data. The request library in Python makes it simple to send delete requests and handle the server's response. In this example, a delete request is sent to https://json placeholder.typico.com /post /1, which is the endpoint for deleting the resource with ID 1. The request.delete method is used to initiate the request. Unlike GET, POST, or PUT requests, delete requests usually don't require a request body or additional parameters, as the URL itself specifies the resource to be removed. If the delete request is successful, the server typically responds with the status code of 200 OK or 204 no content. The status code indicates that the server has successfully processed the request and the resource has been deleted. In this case, the response.status_code is printed to verify the outcome of the request. It's important to note that delete requests are irreversible, meaning once a resource is deleted, it cannot be recovered unless the server has specific mechanisms in place like backups or a recycle bin. As such, delete requests should be used with caution, especially in production environments or when dealing with critical data. Delete requests are commonly used in applications that require resource management, such as removing outdated records, deleting user generated content, or performing cleanup tasks. By using the request library, developers can handle these operations efficiently and integrate them seamlessly into their Python applications. In summary, the delete method is a straightforward way to remove resources from a REST API, and the request library simplifies the process with its easy to use syntax. Understanding how to use delete requests effectively is an important skill for managing and interacting with APIs in Python. Web scraping with requests and beautiful soup. Web scraping is the process of extracting information from web pages, and it can be achieved by combining the power of the request library with BeautifulSoup, a Python library for parsing HTML and XML documents. While request is used to fetch the HTML content of a web page, BeautifulSoup provides an intuitive way to navigate and extract specific elements from the HTML structure. In this example, a GET request is sent to https colon double forward slash example.com using the request.get method to fetch the HTML content of the page. The if block checks the response's status code to ensure the request was successful 200 OK. If successful, the page content is stored in the response.text attribute, which contains the raw HTML of the web page. The raw HTML is then passed to BeautifulSoup for parsing. BeautifulSoup creates a navigable tree structure of the HTML, allowing you to access specific elements using its methods. Here, the HTML.parser argument is used, which tells BeautifulSoup to use Python's built-in HTML parser for processing the content. Once the HTML is parsed, you can extract specific information from the page. For instance, the soup.title.string retrieves the title of the page, providing a quick way to understand the page's content at a glance. The soup.findp.text finds the first p paragraph element in the HTML and extracts its text content. This is useful for grabbing key details or summaries from the page. If the request fails, e.g., due to an invalid URL or network issue, the program prints an error message indicating that the page could not be fetched. This approach is commonly used for tasks like collecting product data from e-commerce websites, extracting news articles, or gathering information for research projects. By combining the simplicity of requests with the powerful parsing capabilities of BeautifulSoup, you can efficiently scrape data from web pages and automate data collection processes. In summary, the combination of requests and BeautifulSoup provides a robust and user-friendly solution for web scraping in Python. It allows you to fetch, parse, and extract data from web pages with ease, making it an essential tool for anyone working with web data. Practical project: fetching weather data from an API. Fetching real-time weather data programmatically is a common task, especially when building applications that require weather updates or forecasts. The request library in Python makes this process straightforward by allowing you to interact with APIs such as the OpenWeatherMap API, which provides weather information for any city in the world. In this example, the program uses a GET request to fetch the current weather data for a specified city, London. In this case, the URL http colon double forward slash api.openweathermap.org forward slash data forward slash 2.5 forward slash weather is the endpoint provided by OpenWeatherMap for accessing weather information. The two parameters are included in the request. Q specifies the city name London. Append the API key required to authenticate the request. The API key is essential for accessing Open Weather Map services, and it must be replaced with your actual key by signing up for a free account on their platform. Once the request is sent using request.get, the server responds with the status code indicating whether the request was successful. A status code of 200 OK means that the request was processed successfully and the weather data has been returned in JSON format. If the request is successful, the program processes the response by converting the JSON data into a Python dictionary using the response.json method. The weather data, including details like temperature, humidity, and weather conditions, is then saved to a file named weather_data.json using the json.dump function. This file can be accessed later for further analysis or display. If the request fails, for instance, due to an invalid AP key, incorrect city name, or network issue, the program prints an error message to inform the user that the weather data could not be fetched. This ensures that the application handles errors gracefully and provides meaningful feedback. In summary, this example demonstrates how to fetch weather data using the request library and store it in a JSON file for future use. By integrating this functionality into your application, you can automate weather data retrieval and build features like weather dashboards, alerts, or analytics. The combination of API engine and file handling makes this a practical and powerful use case for Python developers. Practical project automating GitHub API calls. Automating API calls is a powerful way to interact with services like GitHub, enabling you to retrieve and analyze data programmatically. The GitHub API provides a comprehensive interface for accessing information about repositories, users, commits, and more. Using the request library in Python, you can automate these API calls to fetch and process data seamlessly. In this example, the script sends a GET request to the GitHub API endpoint https://api.github.com/users/octocat/repos. This endpoint retrieves the public repositories of the GitHub user octocat. The request.get method is used to send the request, and the server responds with the requested data in JSON format if the request is successful. The response's status code is checked to ensure that the request was successful 200 OK. If the status code indicates success, the response data is passed using the response.json method, which converts the JSON response into a Python list of dictionaries. Each dictionary represents a repository and contains information such as the repository name, description, and other metadata. The program then iterates over the list of repositories and prints the name of each repository to the console, providing a clear and organized output. For instance, repository spoon knife hello world octocat adventure. If the request fails, the script handles the error gracefully by printing an appropriate message, such as failed to fetch repositories. This ensures that the user is informed of any issues, such as network problems or invalid AP calls. This example demonstrates how to automate GitHub API calls to retrieve useful information programmatically. Such automation can be extended to include tasks like analyzing repository data, generating reports, or integrating GitHub data into larger applications. By leveraging the power of the request library and the GitHub API, developers can create tools that simplify and enhance their workflows. In summary, automating GitHub API calls with Python is a practical way to interact with GitHub programmatically. The combination of requests and the GitHub API allows you to access and utilize GitHub data efficiently, enabling you to build features like dashboards, analytics tools, or automated workflows. And that brings us to the end of this video on real-world use cases of the request library. Today we saw how this library can be leveraged for tasks like automating API calls, handling files, and even interacting with REST APIs. These use cases demonstrate how versatile and practical requests is for solving everyday programming challenges. I hope you found these examples helpful and are inspired to try them out in your own projects. Don't forget to share and subscribe to the channel for more Python tutorials and practical tips. Thank you for watching and see you in the next video.